So here in lecture 11, we're switching gears a little bit. We're going to talk about land surveys in the public land survey system, which is a little bit more of a, uh, not a continuation of what we've learned about in terms of surveying fundamentals so far. It will bring in some discussion about um, like meridians not all being parallel to each other, like the convergence of meridians as we get closer to the poles. But really a lot of the focus here is on kind of I wouldn't call it arbitrary, but a unique system that's been set up for defining property in a legal sense. And so a lot of it has to do, there's a fair amount of history discussion in your textbook, but really it has to do with kind of these choices that were made and how the public lands survey system is set up. And just to kind of go with it and just say, okay, this was set up a long time ago. Maybe we would have done it a little bit differently nowadays. So it takes a little bit of getting used to. And your book doesn't necessarily do you any favors because it does have a lot of parallel discussions about the Canadian system versus the United States system. So make sure that you keep that straight as you're reading through the material. You can just ignore the Canadian content for now. It's not anything that I would evaluate you on. But we'll get into it, and like I said, there'll be a couple tie-ins, like the definition of acres based off chains and the convergence of meridians, but for the most part, it's going to be a fair amount of new material. So it's a pretty quick chapter. There are a couple, basic kind of calculations that we do here, but I'm not having you do a lot of the corrections and not doing a lot of the like conversions calculations and stuff like that that your book might have you do. Very similar to the previous lecture, this is going to be a bit more conceptual in nature. But we'll talk about the basics of land survey, a little bit of the history, not too much, and then talk about the functionalities of townships and sections. And then I have an example. It's actually from the state of Wisconsin. Their Department of Natural Resources put together a pretty good tutorial that kind of walks you through how to provide a legal description for a certain portion of property that I think is a good graphical way to kind of tie all this content together. So why do we have a public land survey system? Well, as long as we've been a country, there's been real property. So real properties is the legal term for real estate, like land type property. And we need to be able to define that. And the way that we did it is we basically set up this system that allows us to somewhat accurately, well, no, pretty accurately describe land. When I say somewhat, it more has to do with like the confusion that comes from kind of the arbitrary choices that were made. But the whole purpose here is that given a legal description for a property, people should be able to find it without any vagueness or anything else like that. So it's been implemented in multiple different forms over the years, and adding to the complexity of this, um, the United States as we know it today hasn't always been the United States of America, right? Like parts of the Southwest were owned by Mexico, parts, of other portions were owned by England or Spain or France at other points as well. And so you'll see some historic kind of elements come into this where as states, transition to the United States, sometimes they honored old property descriptions from systems that are now, for all intents and purposes, defunct. So we're going to talk about the most common ways, like the contemporary way of describing property, but just keep in mind that the public land system, the way that we define properties can be pretty unique. So this is, going down a pretty quick rabbit hole, but we're going to try to keep it as high a level as we can. I'd also point out that some of the stuff that we talked about with control systems and geodetic versus grid comes into this discussion a bit as well too, and that the curvature of the Earth causes some issues, and the way that we've defined meridians basically means that even though let's say, we'll talk about this in a minute, like a section, which is one of the area kind of subdivisions of our public land survey system, is meant to be approximate, well, it's meant to be 1 mile by 1 mile. Not all of them are, and some of it has to do with error, some of it has to do with old equipment, some of it has to do with the curvature of the earth. There's a lot that goes into it, so none of this is as cut and dry as you might hope, but we'll talk about it in broad brushstrokes. So, how is the public land survey system set up in the United States? Basically, it is set up, the largest subdivision that we'll talk about is known as a quadrangle, and a quadrangle is just a fancy name for a four-sided polygon. And so they're not perfect rectangles necessarily. Rectangles would have all 90-degree angles, and quadrangles aren't. Quadrangles they're set up to be approximately 24 by 24 miles, relatively square. Again, not exactly, and partly because of the convergence of meridians. As we get closer to the North or South Pole, the meridians all start getting closer and closer together, and so we start seeing basically like wedge shapes form. Each quadrangle, like I said, is approximately 24 by 24 miles. Each of those quadrangles are split up into a grid of townships, a 4 by 4 grid of townships, and that's what you're starting to see. Like here's a township right here, and then these red lines are the lines of the quadrangle basically. Townships are approximately 6 miles by 6 miles, roughly square. And each township is then comprised of 36 sections, which you see in this inset right here. Each section is approximately 1 mile by 1 mile, so that means each section is approximately 640 acres. Now, you'll remember way back when we talked about Gunter's chains that acres and miles are all defined in terms of chains, and that's why like miles are a goofy number, 5,280 feet. And that's what was primarily used for laying a lot of this stuff out. And that's why we have some, significant errors in some places, more than you might expect with contemporary surveying equipment. The section numbering is kind of goofy. We'll talk about that a little bit later on. But even within each 1 mile by 1 mile section, we can then further subdivide it into smaller rough squares or rectangles that can have varying different shapes. So you see here like half by half or quarter by quarter. There's also quarter by half, which would represent like a quarter tall and a half of a section wide. It all gets very kind of convoluted with the fractions, but we'll kind of peel back the onion one layer at a time. I would point out that the way that these are laid out is that the quadrangles are referenced to what are known as principal meridians. Those principal meridians are like the datum by which everything is laid out, and there are a bunch of different meridians across the U.S. Established in the 19th century, and those are the way that these quadrangles are laid out. And so that's the primary kind of like anchor point for a lot of this is the meridian, which is meant to be just a north-south line like we've talked about in the past. So let's look at the quadrangles in a little bit more detail. So this is actually showing 4 quadrangles. So let me outline one of them. So here's a quadrangle right here. They also have a name. I believe they're also called a check. I'm not quite sure why, but we could probably guess. There's a quadrangle approximately 24 miles by 24 miles. It is referenced to a principal meridian that's going straight down through the center of this. And then each quadrangle is into 16 different townships, and this would be an example of a township right here. And the way that we reference a township is in terms of a township, which this is the arbitrary kind of nature that I'm talking about. Like actually, let's just talk about the one directly below that. This township right here, this 6 mile by 6 mile approximate rectangle is labeled as T2N R3W. And the reason it's called that is that the T stands for township. And again, I know that this area is called a township, but how we reference it includes like township as a coordinate, a little bit goofy. The 2N means it is 2 rows north of our baseline. So I go up 2 rows, so 2 rows to the north is the township, and the range is R. R stands for range, and that is 3 areas to the west of the principal meridian. So this is township 2 north, range 3 west. That's how we would address that township, that 6 by 6 mile rough rectangle. The other thing that I want to point out here is that you'll notice on this right side, we have a standard corner, a baseline, and a closing corner. If we were to zoom in there, we would have something that looks like this at that corner. And the reason that we have this gap right here is because of that convergence of meridians. So as we're getting closer and closer to the top, these lines, like this line right here, is slanted, just like this line right here is slanted as well. And that slant gets, more profound as you get closer to the top, the North Pole or the South Pole. But that is causing that dislocation, so that we can try to keep each of these areas at approximately 6 miles by 6 miles. So just something else to keep in mind. All right, now if we go in a little bit further and look at one of these townships in more detail, again, this is approximately 6 miles by 6 miles. And it's broken up into 36 sections, each section being approximately 1 mile by 1 mile. Now here's where another kind of arbitrary, non-intuitive aspect rears its head. We start numbering in the northeast corner. We run sequentially like this. We go down, and then we go back, and then we go down, we go back, and it snakes across like this. And honestly, I don't know the reason for it. It might be the convention of the way that they went and surveyed it. I honestly don't know exactly what the reason is. Maybe your book discusses it, but I didn't notice it as I skimmed through. But so referencing a range, usually it's just best to look at the figure in your book and then just say, okay, I'm looking at number 14, even though if I was looking at this, traditionally I would think that would be number 17. But the numbering of the sections is a little bit goofy, so something else that you just need to get used to. And then within each of those sections, we're still looking at the township, but as we're looking at the sections, so each section would be, one of these 1 mile by 1 mile blocks. On paper, these should be 1 mile by 1 mile, which is 640 acres by default. However, because of error and because of the convergence of meridians, some of these aren't going to be exactly 640 acres. Usually like 11 of them are going to be a bit smaller. So the way that this works is that these that I'm putting the border around, those 25 stay 640 acres. And then the ones on the west and the ones on the north, they take up whatever error or distortion we have due to either the convergence of the meridians or errors with measurements potentially. So those are usually, I said smaller than 620, but smaller than 640. It's not usually a huge number. I mean, it might be like a fraction of an acre that they are smaller than 640, but most of them are a bit smaller. So again, that's just due to error and that nature of the convergence of those meridians. So the last thing that I want to talk about is a relatively short lecture would be when it comes down to like the legal description for an area or a property. It usually takes the form of something that looks like this. So here we have north 1/2, southeast 1/4, southwest 1/4, south 24, T32N, R18E, which seems like a lot of nonsense, honestly, if you're not familiar with it. And so this legal description, we usually kind of read it backwards like this, because on the far right gives us like the furthest zoomed out version of what we're looking at. So this is an example from Wisconsin, but the same rules apply to Oregon as well. So let's just kind of walk through so in terms of the way that Wisconsin is set up, they have a principal meridian that basically splits it into an eastern and western ranges within Wisconsin. And the first indicator in this legal description is R18E, which basically says range 18 east of our principal meridian. So here's our principal meridian right here. And so then 18 to the east of it are all of this column of townships. All of those have a range of 18 east of the prime meridian. So we've got the first kind of indicator. It's going to be one, it's going to be in this column for sure. We just need to drill down a little bit more. So the next thing that we can drill down would be the the township. The north kind of coordinate, if you will, of a township is called a township. Again, it's a little bit goofy, but either way, T32N. So we're looking for the square, the township, that has a range of 18 east and a township of 32 north. And so that represents this row right here. And so where they intersect is this township right here. So that township where the arrow is pointed to has a coordinate, if you will, of township 32 north, range 18 east. Now that's a big space, right? That's a 6 mile by 6 mile square. And so we need to drill down a little bit further. Well, that 6 mile by 6 mile square is broken up into 36 sections, and we care about section 24. I think I might have said South 24 before. I meant to just say S24. Well, based off the diagram that we have for how the goofy numbering works for the sections, this would be section 24. And so we're just drilling down further and further. I'm in that section 24, that 1 mile by 1 mile grid. And then within that, I know that I have these other descriptions that we need to deal with. So the first would be within that 1 mile by 1 mile section, we will be focusing on the southwest 1/4. So we can break this up into quarters, and it would be the southwest 1/4. So it would be this 1/2 mile by 1/2 mile area, right? It's a quarter of the total area. 1/2 mile by 1/2 mile is going to be a quarter. And so 1/4 of 640 acres, this is a 160 acre parcel. So within that southwest 1/4, we can further break it up into another area. So this 1/2 mile by 1/2 mile square can be broken up again into quarters, because that's what it's telling us to do here. And now we're focused on the southeast portion of whatever is left over. So now we're in the southeast quarter of the southwest quarter of that section. And again, it's this nested kind of cardinal direction, but graphically, I think this is a really good example to show you what's going on. And then finally, that 1/4 mile by 1/4 mile area that we're left with, we are just focusing on the north 1/2. So we went from 160 acres down to 40 acres, and now half of that 40 acres would be the remaining 20 acres. And so that's how it all drills down. But here is obviously going to be the most confusing part. Read it from right to left, go from the broadest down to the narrowest, and that's going to make your life quite a bit easier. And so here's another kind of graphical representation showing you how all of those little, quarters and halves look graphically. But that's how you would go from finding your township, finding your section, and then going through the different breakdowns of which quarters or halves get taken out.